But welcome. Thank you for coming. My name is Ayush Maganahali. That is indeed my picture at the bottom here, which may be surprising to a few based on how I look now. Let's just say that COVID has definitely done a number on me, and it has still even a year out. But glad you could join us for building data pipelines with Snowpark. Today, we kind of just want to go over the basics of how to kind of like work with Python, how it might stack up against SQL, which many of you will probably be working with in at least some capacity in data pipelines, whether it's kind of working with other people to kind of tell them how to maybe get commands out, or working with it yourself. Why might you use Python instead of SQL here or there? And for that matter, why would you use Snowpark in certain cases, which, as it's a Snowflake specific solution, what are exactly the advantages there? So with that being said, let's get started. And the agenda for today will kind of be one, kind of what are the fundamentals, right? For those of you who maybe don't have any Python experience, given that this is supposed to be a beginner-friendly version, there will be maybe more intermediate or advanced level courses / talks later on. What are the fundamentals here? Kind of how do you approach Python? How do you approach even SQL in certain aspects? And where do those merge? Where they have commonalities? Where do they have conflicts that might promote one or the other in certain cases? Kind of going over all of those sorts of concepts. Second, we'll be having a hands-on, or sorry, maybe not quite second, but we'll go into a SQL to Python conversion or a hands-on lab, kind of whichever is more convenient based on the time period or how we're feeling people's ideas are at that time. And then lastly, we'll kind of be going into APIs for data warehousing. What is Snowpark really doing for you? And then at the end, we'll have like a small little cheat sheet for how people can, work with Python or learn a bit if they haven't seen it before. So diving in, what are the fundamentals, right? And when we talk about fundamentals, what do we see every day kind of here at Ascend? Well, a lot of things that we see at Ascend are related to data engineering, right? The whole point of coming to Ascend is for data automation in your pipelines, working with pipelines, and working in the nitty-gritties. So when you are working with data pipelines, you're naturally pulling from data sources. Those data sources can be from anywhere, right? Databases, files, API streams, but you're getting your data from somewhere, and these will be large data sets, large data sources that you are working with. And generally, you're going to be working with Databricks, Snowflake, Google Query, some sort of like data processing or storage unit that you want to be able to keep all your stuff in. Then from there, you're going to move into kind of data transformation and automation, how exactly we are handling those sorts of scenarios for you and making sure that you are able to manipulate the data how you best want it, and eventually pushing it to a centralized location. It could be in the exact same places that you had pulled data from, but the point is that it can go in and out of your systems fairly easily. But the idea you want to maintain here is that you are working with very large data sets, right? That is a key and pivotal thing in data engineering in the modern age. So then what is Python really about, right? Like when we talk about Python and SQL, it's almost always in the context of data engineering, given that it's at the forefront of tech today, but it's always Python and SQL, right? You don't see many other languages such as Java or C, big names that you may be taught in school, but aren't necessarily as prominent in the field today. So when we talk about Python, the first thing we should probably cover is the history of Python, right? It was founded in the 1990s. Python 2.0 is out by 2000. So given the length for which CS has been around, some of the older languages, going all the way back to like maybe Fortran, coming up to C or Java, those have been around for quite a while, right? But this is a fairly recent language coming in around 2000, especially with the heyday of Google. And then the idea central to that was that it was created to be a scripting language, right? It's easy to read, better than shell scripts, and definitely understandable even for the common user, right? And that comes with its own tenets. It has about 17 to 19 of them, and some of my favorites are listed here. Readability counts, definitely, I think the first thing people notice with Python. Another nice one is special cases are not special enough to break the rules. And then this last one, maybe being Dutch is an advantage in computer science, but that remains to be seen given how it is now taken worldwide adoption, right? And so given that we kind of maybe know a little bit more about Python, and I know that was like a really brief and quick introduction to it, but we've gotten the sense of it's readable, right? And that's the primary purpose behind it. So then why do people use it? Well, first and foremost, it's simple and readable, right? And that cannot be overstated enough. With mass widespread adoption of CS nowadays, your language kind of has to be easy for people to jump into. Otherwise, it's difficult for people to continue working with it, right? Especially for the layperson who maybe doesn't have as much CS experience or isn't working with it on the daily. It's not really worth the investment to have to go and learn how to do memory management or object-oriented programming and whatnot. So while Python maybe does involve some of those concepts, a lot of it might be abstracted away to make it easier for a regular user. But on top of that comes a lot of nice things, right? You have a gigantic ecosystem. It's open source. Things are still being edited today. Many of you are probably on Python 3.11, which is still a far cry from Python 2.0, even though it's only been like 2 years or 20 years, excuse me, not 2. But since it's been 20 years, we're already on Python 3.11. There's a lot of new things that you can work with. It's scalable and performant. It's portable, meaning that it can work across platforms, whether you're on a Mac, whether you're on Linux, whether you're on Windows, whatever your OS is of choice or architecture, it's going to be there for you, right? And there's very few cases where it can't, and with modifications, it probably can be anyway. And lastly, it's integrative, right? All of these are kind of alluding to the fact that regardless of what you're on or what you're doing, you can work with it. Python is there for you and can always be used regardless of what you're doing, both in or out of the software. So now that we've gone over like a very brief introduction to Python and maybe what exactly it's going about, what is SQL, right? What's the other side of the coin that we are talking about today? So for SQL, it is a much older language, right? It is nearly double the time span of Python at this point, where Python came out in the early 1990s, really took on its shape and form in the 2000s. SQL was much more prominent as early as the early 1970s, right? There have been various iterations since. Obviously, there's things like MySQL, Postgres, very different variations on it, depending on the company who produced it or who's using it. But the thing I want to point out to you is that just like Python, it is designed to be usable for non-programmers or the regular user, right? It is not intended to be this complex foreign language that only niche specialties can learn. The point is that anybody can learn it and it will be relevant for them. And so just like Python as well, it comes with its own rules. These ones are a little bit more boring, so I'm not going to get into the details about them or point them out too much, but you'll notice that maybe some of the things that you work with in SQL, or you notice how some of the trends of the things you work with in SQL are tied into the rules that are established here, right? Because these rules are coming from as early as the 1970s and are still very much a key factor in how we work with it today, right? So for example, values being accessible by using a combination of table name, primary key value, column name, very similar to how we do things today, if not exactly on point. Changes to table structure should not require these complicated programs. You should be able to just kind of change the table structure as it is, right? You don't need to have a separate foreign application. And so with that now in mind, and again, try to keep what you thought about Python in mind as well. Why do people use SQL, right? And we'll get into the comparisons in a little bit, but just try to bear with me through, how exactly you might approach this without knowing about the other for now. Well, it's anything database related, right? Database creation management, data modification analysis, data integrity, data security and control. Because remember, SQL is built for databases, right? This is a byproduct of, being one of the earlier languages and to work with its own niche programming. But as a result, it does everything database and it does it well, right? There's a reason it's still used today. And that's because you can do pretty much anything you need, anything database related, because something as different as security and control, as opposed to data modification analysis, you can do all of that within one language, still a very convenient language, especially given how scalable and performant it is as well, right? So with that in mind, and hopefully some of you are pretty familiar with this as well, let's kind of get into comparing the actual Python and SQL, right? And we're going to break it down into two main ways and just one visual way so that you're able to kind of start getting an idea of what the two are, maybe visually if you haven't seen it before. But the biggest and foremost difference between the two is that Python is imperative and SQL is declarative, right? And for those of you who maybe don't know what that means, in a very, very brief sense, and this is one of the core concepts in Ascend nowadays, is what is imperative versus declarative? Imperative is you are using that language, in this case, Python. You are defining how things are going to occur in the control loop. And so what we mean by control loop is if you write a program, you are going to tell the system how exactly it should run, how exactly it should handle the case that it is to achieve the result at the end. You're not telling it what the result should be. You are just telling it, if I give you a certain style of input, it doesn't necessarily know what the input is. But if I give you a certain style or type of input, and I give you this control logic, I expect, in your head, you'll expect some sort of output, and you're telling the system, it should probably give me an output like this. But the system will give you an output based on the input with no decision on what exactly it should look like, just purely based on that. Whereas for SQL being a declarative language, right? And this is the other side of things, is you are going to tell it, I want this information by the end. You are going to tell it the style of information that you want. For those of you who have worked with SQL, this is your select statement, right? Like, what columns am I looking for? What maybe are they named in this way? Are they this type of column when you cast it, right? So you are telling the system what to do, but it's not as though you necessarily know how exactly the query is going to be optimized. This is, for example, where Snowflake, Databricks, they all work within their own systems to make sure that it's as optimal as possible. But you are not privy necessarily to how exactly that is achieved, right? And that's the point of a declarative system. It's that it's able to handle that for you, and you don't have to concern yourself with having to work that out on your own. So keep that in mind, because with Python, you can define basically your own stuff. And with SQL, you're less worried about that and just getting optimal scalable performance, especially with databases. And speaking of databases, we're going to jump in a little bit to the functional programming and database programming side of things, right? Because with imperative versus declarative, sure, that might be the case, but if they were both database programming languages, well, Python is you writing your query and defining the query, and SQL would just be you declaratively saying how to do it, but it handling it for you. But when their difference is also functional programming and database programming, well, if Python is functional programming, where it's much more general purpose, it's going to do a lot of things fairly well, but it's not necessarily going to be the master of one, right? As SQL is with databases. With Python, you're able to kind of interact with a lot of different things, do a lot of different things, have a lot of different libraries and frameworks, given the way Python is open source and is available for a lot of these sorts of things. But with SQL, maybe not so much so, but definitely does, like I said, databases really well. So again, keep those things kind of in mind, and those will probably inform a lot of like the ways you might want to think about Python and the ways you might want to think about SQL when you're actually working with them. And so those should hopefully cover, the main ideas underlying the difference between the two. So we're just going to kind of pop in a quick, syntax check here for those of you who haven't necessarily seen them before. On the left here is a Python program. Something that it's not code that you would probably actually write, but it is something that is very much in line with how you would actually write Python, right? You might import a random library here, and by random, I quite literally mean random. And you would define a function as so, right? But the point of Python syntax, you'll notice here is also that it is quite readable, right? Like if you know that def means definition, or maybe you're able to extrapolate that, you'll know you're kind of you're defining something, and then probably things to the right are indicative of that. There's an equal sign for assignment. It's pretty easy to figure out what's a string, what's a variable here and there. The for loop, nice syntax. So you're kind of seeing maybe that it is as readable as people, intended it to be. And similarly, on the right, we have a, SQL statement, which a lot of you are probably more familiar with. And so for that case, you're able to get things here and there, filter out what you need with the where clause, where you're pulling it from with the from statement, group by, order by, limit. Fairly common stuff for a lot of people. They have seen this in some capacity. And if you're using a keyword, it usually does a pretty good job at stating what it does on its own, right? Cool. So now that we've put them side by side, when do we use Python, right? The main purpose of this talk is trying to figure out when to use Python. I think for a lot of data engineers and data analysts, they know pretty well and like where and when to be using SQL, right? It's fairly straightforward. If you're trying to work with data, you can use it then, right? Nothing too difficult. But when it comes to Python, it's a little bit stranger, right? It's functional, it's general. You kind of have to learn how to do it and create your own solution. So it's definitely a little bit more difficult and has a little bit higher barrier of entry, excuse me. But these 6 cases, I think, are things that we have found that generally are pretty good at, or Python is pretty good at, that SQL maybe doesn't handle as well, right? And so the first is complex logic. And the second is user-defined and custom functions. And that will be primarily what we're going over today. And the reason for that will be, okay, when someone is jumping into Python, they are probably not going to first work with version control or CI/CD. They're probably not going to work with data pipeline orchestration, given that we are also here and trying to do that for you. But the point is that people can, still write their own code and create these like complex logics with fairly basic understanding of a programming language. And when we say complex logic and user-defined custom functions, right, you might also be used to like user-defined functions in SQL. It should very much be in the same line. But given that you can dictate, okay, like I want my for loop turning this way, I want like my while loop turning this way. This is like my actual like function, right? Where it's not necessarily gated by, oh, like maybe these are the aggregate functions that I have available, and it's difficult for me to create a custom aggregate function. It's much easier to do that in Python, given that you have more granular control, right? And so with these complex logics and functions for you to kind of play around with, it's definitely a lot easier to do that in Python than it is in SQL. And so on these last items that we didn't touch on, we touched on version control, data pipeline orchestration, things like, Git, Jenkins, or like where are you pulling things in from? Data pipeline orchestration will be, okay, like how exactly is my pipeline running? When should I run it? Those sorts of things. In an external system, like external to Ascend, you would probably need a programming language to dictate that, right? You're not going to sit there every day at 9 a.m. and say, okay, click now, it's going to run. So you're going to automate that. And that'll be almost certainly used in some sort of functional programming language. But then also, given the breadth of Python and how it's a general resource, you can bring in a lot of external systems, APIs. It doesn't need to be localized to a database or a specific resource. You can just kind of say, I want this library. It'll pull in from this API or this area, and Python will do that for you. It's not that difficult. And similarly, testing and debugging. Python has numerous libraries. IDEs are built for that as well, but it's got the framework in place in order for you to do that. I think we ourselves have also released or soon to release at least, a testing framework in order for people to test out their own components, things like that. And all of that is built on Python. And the reason for that is because it just is easy to do there, right? And so when you can kind of build and define your own tests and frameworks and those sorts of things, pretty nice to do rather than running through full data sets or trying to limit it to a certain area in SQL. So now we've gotten into the specific use cases. And before jumping into the hands-on lab, just want to quickly cover, Python to SQL for those of us who haven't, covered Python before. And so again, the reason we're doing this is we might have future sessions on where we'll cover a little bit more dynamic concepts or more complicated concepts. So definitely, if you're finding this maybe a little boring, just hang on for a little second. We'll be there to the actual like working within Ascend portion within like 2 or 3 minutes. But for those of you who haven't seen it before, on the left, you have a SQL command, right? And on the right, you have PySpark on top and Snowpark on the bottom. Apologies for the snowflake symbol. I couldn't quite find a nice Snowpark logo there, but Snowpark is Snowflake's take on how to have a Spark integration. This is going to be their API calls and those sorts of things. But the point here is to kind of point out the similarities. So on the left, we're filtering on vendor ID, a column. And on the right, you'll notice that this is how you might approach it by calling the column there, right? You can call it in multiple ways. You can use f.call. So in this case, f is just referring to like PySpark SQL functions or Snowpark functions. That'll be like a library that you pull in. But just for the sake of space, we kind of have it like that. But this will be also the convention by which things are. This should be a standard thing. And so you'll generally see columns referred to like this, usually within square brackets as such, or within the parentheses within column before it. Green cap, for example, is a table that we're pulling from. And you'll notice this is how we might call it in there, right? We call it GC, short for green cap, and then a df after to refer to the data frame. The where clause becomes a filter as the functions are there. And the point is that the syntax should be, lining up in your head. Where and filter should be pretty straightforward and being like, oh, okay, like this probably does that. And maybe the syntax is different in terms of the exact terminology, but it should be pretty straightforward when you look through the documentation to be like, okay, that's probably what this is. Cool. And this will be our last example, but I'm just going to point out a few things here, not the whole thing. So group by, which is another common function in SQL, will also be called group by in PySpark and Snowpark. As we mentioned, the syntax can be fairly similar to the point where it is literally the same thing. As will be alias, right? But the thing I do want to point out is that we also have this aggregate stuff, right? Where there are similarities, there are also differences. And so this aggregate will be necessary afterwards to indicate that you are going to have these aggregate functions, such as on the left, you see variance, min, max, average, sum. On the right, you also see variance, min, max, average, sum, but you have to indicate that these are the aggregates that are occurring there. Whereas in SQL, you can kind of just let the aggregates rip and they'll take place on their own because they're already within the select statement. So just keep note of these sorts of things. These will be very much things that you will want to pay attention to as you get like deeper and deeper into these sections. One thing to note is that you might notice that the group by call occurs first, whereas to the right, as in later, comes like the aggregate or the aggregate functions, excuse me. But the first thing to note is that actually what will occur is the right-hand side first in this case, right? So this will be what we call lazy evaluation. And so it will wait to handle the group by before you are going to handle like the aggregates. It will note that the aggregates are going to occur and then handle the entire group by at once. It's not going to say, oh, okay, like group by this, and then suddenly mess up what's happening on the right-hand side because it wasn't aware that an aggregate was supposed to occur and just kind of jumbled things up. No, it'll note that there are aggregates about to occur and then handle the group by. So cool. Hopefully this, I know it was a little bit fast, especially for those of you who might be new to Python, but this should hopefully give an introduction into what exactly we're talking about, which is the hands-on lab. And before we switch screens over to the lab and kind of going over some of these, how to create like these resources and those sorts of things, we do want to note that we do have onboarding sessions every Tuesday, and we might also have future labs. The future labs are a little bit up in the air, but the onboarding sessions are every Tuesday, where you can kind of come with me, another person, another engineer in Ascend, and we can walk you through, any struggles you might have, any questions you might have, anything you want to work with in person. This is a good opportunity to do that. So we definitely recommend doing that. But even then, thank you for coming today. And hopefully this should give you a good introduction to both Ascend and Python. Cool. So let's switch over. And this link on the right, so at developer.ascend.io, docs create a Python pipeline, we will be following this information here. For those of you who have received an email before for maybe like a sign up link and whatnot, we did also mention that there were these quick start guides. If you did do those quick start guides, you might notice that on the left here, where we have the actual code and Ascend environment, is the somewhat familiar yellow cabs, green cabs, weather API, raw, weather stations. These are read connectors we've worked with in, you might notice on the right, where we say create a taxi domain, weather domain, data mesh. Those are the same read connectors from there. So we're going to be using the same data here and going through this document. And let me see if I can link this in the chat so that people have that to go off of. Not sure if Ishita already linked it, but hopefully this should be there. And if not, someone please do let me know. But we're just going to get started on this. I'm going to go through this fairly quickly in the sense that you might have to write the code and those sorts of things. But for now, I think we're just going to go through it as like a walkthrough, and definitely feel free to go over it. One thing I do want to note, because we have worked with these kind of things in person before, you can copy and paste the code. Please remember that you do not have to, drag over it and copy the code. You can just click the button in the top right to copy it. Cool. So with that being said, the first thing you're going to do here, especially, and we do recommend doing the first 3 labs first, because those will be better introductions to the Ascend environment and understanding what is even happening, so that you don't get immediately lost in saying, okay, I don't even care about Python. I don't really know what's happening here. Those will be great introductions. So I definitely recommend going over those afterwards. But the more important part is when you create a read connector. So we're telling you to create these 4 read connectors on the left, which I already have pre-created. But they will end up looking like this, right? And we'll walk you through that. Don't worry too much about getting access to the data. This should occur when you already create a cloud account, and you should have access to these buckets. But for example, in this S3 connector, as we call it, which is just pulling data from S3, you can see that we connect to a specific bucket based on the kind of pattern matching here. And let me go into edit mode so that you can kind of see what are your options that are available. You can go glob, you can go match, prefix, regex, kind of whatever your certain scenario is, or which sort of files you're pulling from whatever directory or hierarchy, you can kind of pick whatever best meets your use case and pull from there, and then get whatever data. Here you can see that we're pulling all the data from within this directory or these subdirectories. So NYC taxi, yellow cab, 2016, so January 2016, and any file in there, and parsing them as their CSV files with a CSV parser, right? And we know that this will end up in this schema. So if I hit generate schema now, it'll automatically produce that schema and produce a record, right? For those of you who've done the lab before, or the previous labs, excuse me, this should be very familiar. But this should be a preview of the records that you have, and that'll be the sort of data that we pull in. And I'm going to pop this open, because this should be the end result of what you did in those previous labs. Excuse me for the zooming in and zooming out. But this is all just within one pipeline. For those of you who have done them in 3 separate pipelines, this would be slightly different because they will have data feeds, be broken up a little bit more. But this is what it'll end up looking like in person, or as one singular data pipeline, right? And so as a result, you'll see we have all this. And by the end of this lab, what we're going to end up doing is we're going to use this specific transform to produce up to this point in the pipeline. So we're going to collapse all 7 of these into this, right? And these 2 are the final results that we, would present to people maybe analysts or those sorts. And so as a result, we have those still here. But for the rest of them, we could collapse them into one Python transform, where it might get super complicated in SQL to handle all of them. And so as a result, that might be something you could do. But let's start with a little bit more basic of an example, right? So we're going to move on to kind of step 2 here. Step 1, we were talking about recreating them. And the reason for the lack of that is you can go back to the previous labs in order to create them there. They will have the instructions for them. But in step 2, we're going to talk about a basic Snowpark transform, right? So in this case, we're going to talk about this one down here, alternating case. The way you can do that is, you can click here, create new transform. And so you can do this for all of these, but I'll just go over this once. So you can create a new transform and it'll pop open what will effectively become this. And then you can go ahead and name it alternating case or whatever you really feel like. Doesn't matter too much what the name is. Feel free to specify that you want a Snowpark transform. If you want to work with PySpark, feel free, but we are working with Snowpark here. Weather stations will be your input. If you switch this, it'll switch to a different one and your code won't really make sense at that point. But here you go. This will be a basic kind of transform that we're working with. So to be clear, I just want to kind of do this for new people. Creating a new transform when you initially load it into Snowpark or PySpark will initially look like this. You'll have the input already defined if you click that version, but you can just map all partitions one-to-one and it'll come out looking like this, right? You already have your basic libraries pulled in that will have kind of like when I was talking about, the functions before, this is what we were talking about, any types, those sorts of things that are probably necessary. And then you'll have this basic, input where we have one input. So we have just input 0 defined here and a data frame. And we are returning it, right? But for you, where you want to create an actual, section of code, what does it end up looking like? So let's take a look, right? Here, it's a little bit of a silly case. All we're trying to do is create a string or replace a string where it came in all uppercase, and we just want to lowercase every second letter, right? And so what we're going to do here is say, okay, we got our inputs, right? We know that this is the weather data because in our case, we're pulling from weather stations, right? And so if that's the case, then we're just going to call it weather's data so that we know what we're referring to. And we're going to define our function, right? So this is a nice part about SQL where in Python, where in SQL, you might, create subqueries and whatnot. You can just outright create the function. I know there are situations where you can create functions in SQL, but those are generally not as prominent as they are in Python. And here, what we're going to do is we're going to create an output string. One of the, things of Python that you might not know, or one of the, specifics is you cannot mutate a string, as in you cannot change the string, right? And so you would have to create a new string in order to change it. So we're going to have this new string here. We're going to iterate through whatever the input string was, right? And so these are our inputs. So we just have one input string. We're going to iterate through that where we know what the length is. So we're going to go through every index there, right? So this I, and so that also the comments here will help you if you get a little bit lost or are looking at this afterwards. But when you have the length of it and you're going through every index of it, you're going to say, okay, what is the character that we have at that point, right? So in this case, it's a letter of a word. So what is that character? And what is the index that we're at? Is it 0? Is it 1? And since we wanted every other one, right, to be lowercase, then we're going to check whether it's divisible by 2, as in like, is it an even odd index? And if it is an even index, we want to keep it capitalized or capitalize if it's not. And if it's an odd one, which is again, every other, then we want to lower it, as in make it lowercase in case it's uppercase, or keep it lower if it's already lower. And at the end, we'll just return the output string. Then at the end, or sorry, not at the end, the function has been defined, right? So this is the function that we want to work with. This is our custom function to create, a specific case that we want to work with. But within Snowpark, right, we have that function defined in base Python, but we need to create it in Snowpark. So what's going to end up happening here is we are going to create a user-defined function. So what in the Snowflake Snowpark functions library, right? So we call that F here. We're going to use that UDF defined in that library. So UDF refers to user-defined function. And here we have a couple things. We're just going to say, okay, we're passing in this, this function that we've defined up here called alternating case. We can have a specific return type. In this case, we're returning a string type. So we refer to it as a string type. And again, t.string type is referring to the string type defined in Snowpark. And the input types, which we also have defined, is a string type, which, an input string should be what you're putting in. And now that we've defined the UDF, we can assign that to a variable and say, this is our new, UDF function that would actually utilize Snowpark as it's intended, right? So parallelization, working with it in a very vectorized format, rather than the Python version, which would go one by one, right? And so, or at least it would expect a single string rather than a column of strings. And so now that we've done all the work in order to create an actual function, a user-defined function that can work with Snowpark, we're going to actually add the column. We're just going to call it, right? So we put the function here and then pass in the column that we are trying to change. That will be added as the alternating name column, which is what the with column function does. Create a final data frame and return that data frame, right? This will be the output, or what's at the end of like a SQL query, right? Just a table. And that will end up producing what we see here. So again, name was what we input, right? So something like St. John's, and we end up seeing something like this for alternating cases, right? So one thing you might notice here is, for example, like T and J are both lowercase. Why is that? That's because this is index 0, this is index 1, and then the space in between is index 2, and this is index 3, right? So both T and J are on odd indexes, which is why they are odd. But it looks like our code worked as it's intended, right? Maybe it didn't work quite what we intended to do because we didn't specify in the control logic, oh, skip spaces or non-character lines, right? Not non-white spaces. But we told it that every index, every odd index should be lowercase. So it did exactly that, right? And for that, for all intents and purposes, it did what we expected it to do. And you can see that it worked through the entire column like that, right? Whereas in Python, it would expect just this string and just this string, right? Not the rest of these rows or columns, right? Just that one singular input. So that's why it's so powerful to work with, Snowpark. It's definitely capable of, parallelizing a lot of work that you would need to do. And one of the reasons we definitely recommend it, especially when you're working with tables, this is what allows Python to be able to work the way it does and why it's so scalable. Cool. So hopefully that should be like a very, kind of fun interaction with Python, maybe a more, business-like case where you might actually interact with these sorts of things. I'm going to skip over again. This should look familiar, and you're going to end up with a, better transformation than if you had actually added the code. But now let's say we're working with the yellow caps data, right? And apologies for not following along here, but you have all the code here for part 2. Now we're on step 3. And again, you can copy all the code here. But this code will be taken from the yellow caps read data that we had earlier, read connector data. And so what you notice here is that, like mentioned before, we have the yellow cabs data frame as our input, right? So we call it that. And then we define our function again. We call it per user statement by distance in this case. And this time we have multiple inputs, right? We have a distance, we have a passenger count, and we have a string, right? Distance and passenger count, I'll give you a little bit of a spoiler, are intended to be numbers, and input string is intended to be what is called a string, right? But in this case, and I'll get to a little bit, we're going to have to split our string up by space. So this is a built-in Python function that will split it by space. And so if you're given a string of, say, like St. John's, like last time where there's a space in between, it would instead become a list of the words Saint and John's, right? So that's what this is intending to do, but it's instead now a list, right? So we can iterate through it, or at least by the individual words. And so in this case, since it'll actually be a string of numbers, we're just iterating through it, and each of these will represent a value. We, again, make that into a number this time. So by casting it into a float and then dividing it by a passenger count, which as we set up here is intended to be a number. This might be a little confusing, but when you see the data, it might make a little bit more sense. But the point of what we're trying to do here is we are going to define this function. We've done most of the work here. But the important part is we want to take the trip distance that we eventually get, round it, as you can see we're doing here, and then create a new column called rounded trip distance. And you're seeing this final output here. This is because we dropped the columns at the end. I'll take that off at the end so it makes a little more sense. But then we're going to group by. You can see here like rounded trip distance, passenger count. These are now what we are grouping by. And then aggregate into lists. So we will create lists off of this that will, be lists of these values. And these will be what we end up passing into here, because what this function actually does in Snowpark is create a string rather than a list, but they will be separated by what you notice here, spaces, right? So it's an important thing in Python to understand what exactly is happening with the functions that you are working with and keep those in mind, because they're a little bit less self-explanatory than SQL, where the keywords are quite indicative of what they do. And here you might want to check the behavior you do, because it will kind of inform you how you have to work down the line, or change it now so that you can work with it more proficiently later. And then we'll do what we did last time, right? Just create the UDF version of it, take what we built in Python and create a Snowpark version of it. This time we are expecting to return a list of values, right? But we are getting into it in integer type, and a string type. Remember what we mentioned up here is that this is a number, and a string. And that's what lines up with what we see down here, an integer, and a string, right? So now that we've defined our UDF function, we are going to actually call it. So we're going to call it separately just for readability purposes, but you can just as easily plug it into, what is here. But we're going to call this UDF function on our rounded trip distance. So this column, passenger count, this column, and then fair list, which is a column we've deleted for now, but I'll show you in a little bit. So that makes more sense. And then we'll get our output. Similarly, so we did this for our fair column, and we did this for our payment column. So what we call amount list. And then we're going to add these columns to our list and then drop, the old data so that it's easy to read here, because otherwise this would be a lot longer, and you'll see that in a second. But hopefully you should realize what we've ended up creating is one column, another column. These are our group by statements. And then the list of data for how much, was paid per customer when we actually divided them as such, right? And so this is a per user fare. So let's go ahead and edit here. We will take out this statement for now. And so what this will end up doing is it'll run through it because we changed the code. And so for those who are new to Ascend, this should very much be something you become familiar with. When you change the code, this should indicate that there's something different. And when Ascend detects that there's something different, it will run it anew. So then what you'll notice here now is suddenly we have the round trip distance passenger count, but also the fare list, the tip list, the amount list, kind of the values that we came in with, right? And so these will be the values that are passed into our UDF function, and that you'll see we remove them, but they will be transformed in the UDF to become the data that we need now. So I'm wrapping up here. And so, yeah, so you'll see here that these are, strings that are, separated by whatever it is that we're looking at. So in this case, the fare list here, a string that is space separated, similarly with tip list. And you'll notice here that we have, some float values here and there. And then lastly, to the right of that is the amount list. So 30.3, 31.8. And so the whole point here is that you can take this and apply these things over like a for loop in order to work with it more dynamically than you could in SQL, where it's a little bit more difficult to work with a list or with custom code as it is. So hopefully these cases should be a little bit explanatory in terms of what exactly is happening here and what exactly Python is good for. I think in most cases, we find that Python is very useful when you are dealing with control flows, right? And control flows are referring to, in Python, what are generally while loops or for loops. The function is part of a control flow, but that is kind of inherently part of a UDF. And so as a result, what this ends up doing for you is you have much more granularity on the process of iterating through things and saying, okay, I kind of want to change things here in this way. And so when I'm able to go through this and say, okay, at this specific location or at these specific locations, do this action, but in these locations, do this action. It's a little bit more easier than saying, okay, like case when, like, what are we doing here? But this is the whole column. Like I don't have any granularity on the actual value itself. There's a lot more granularity you're able to interact with and say, okay, this is what we're able to do here. So we did that with a string, which is something we can iterate through. We did that with a list, which is another thing we could iterate through. And so both those cases are similar for a reason. It's where we generally find what it is. The thing I want to reiterate here as well is that if you are feeling like maybe Python covers some cases here and there that aren't quite, as powerful as SQL, or you think that SQL might still be powerful, there's a reason SQL is used, right? It is still very much in line with a very powerful tool. It can do a lot of things for you that you don't necessarily need Python for. But Python, like I said, is a very useful tool to keep in your back pocket that you can use multiple, if not all the time, to be able to achieve what you want. So that's kind of what we're trying to allude to here. Cool. So we have covered some pretty basic cases, and with that, pretty similar code, right? Nothing too difficult in terms of seeing the parallels between, okay, like here's what might happen here and here's what might happen here, especially if you're moving from SQL to Python in terms of like a single query. But what happens when we are trying to combine all of these 7 queries, right? Where if we try to combine this into a single SQL statement, so for example, let's just take one of these, right? This is a fairly straightforward SQL. Okay, this may be the best one, but it is, parsing a JSON string and getting the value from there, right? And so, but at the end of the day, this is just a basic select statement from a table or a string in this case. But let's, look at what it might be from the table. This, for example, is just selecting a bunch of columns, maybe inserting a couple there, but for the most part, maybe just renaming them or aliasing them so that they're easier to read, and then unioning the data that exists for all of them, right? So these are not like super difficult. These aren't intended to be, these difficult SQL queries. But then what this ends up ballooning into in terms of SQL will be these large kind of bulky queries that'll have many subqueries, or you'll have to do like a bunch of complicated logic in order to handle them. And then it becomes a little bit more difficult to be readable. It's hard to pass on to another person and say, okay, like this is happening here, and then this becomes this, and this becomes this. And we're not saying you can't break it up. But one thing we've noticed in Ascend here, especially when you're breaking up these sorts of things and you're trying to orchestrate the pipeline, is it is very much possible for multiple pipelines or multiple transforms, excuse me, that are back-to-back, small, don't really need to be split up, that they become much heavier than they need to be, and heavier in terms of workload and lowering the throughput, right? And so the reason for that is because when you create a new transform, we will have to have overhead in terms of running the query. So this will be an individual query. This will be an individual query. So we have to constantly allocate the context for having to be able to run this individual query. Whereas if you kind of push it all into one transform, there's much less overhead that needs to be allocated in terms of running it per transform. And so even though this might be a little bit more of an Ascend specific topic in terms of what are you kind of cutting out here? Well, it's the overhead. Well, I don't really see overhead when I'm running like an individual query or whatnot, right? Or even in your pipelines where you're running 2 or 3 with your own custom build stuff. You will still run into this issue the more you kind of, create a larger and larger system that an enterprise will work at. So this is why we think that this is another use case where, we're getting complex logic, not from maybe the code itself specifically, but from the idea that you need to maybe condense things a little bit and trim out what exactly is occurring there. So let's take a look at this. And for those of you who are new to Python, this will be probably a pretty daunting look because the code will actually extend up till here, which is about like 100 lines of code or so. But bear with me, this is not as difficult as it looks. And for some reason, this does not have the comments that are in this section of in step 4, excuse me. I have been forgetting to keep moving forward, so that's on me. But hopefully you've been able to kind of keep track of it on your own. But the point here is that this will have the comments that will kind of describe what's happening here. And I'll say it verbally, but hopefully this should be something that you can follow along with. But we'll just quickly go over, some of the things that are happening here. So for example, we are getting our inputs, right? We saw Python transforms where you only have one input here and there. But in this case, we have 4 different inputs, right? Because we're using all of these data sets in order to work with the data that we want. And so these will all be their own individual input, and then they're all their own data frame, right? I forgot to put, the data frame or df suffix here, which is usually the common standard. But, doesn't really matter in terms of the actual functionality of the code. And then so from there, you'll notice that, okay, we have all of these things going. So here, what are we actually replacing, right? So when we see this code, what is the parallel we're trying to draw from here? We're actually referring to this all cap data. So this you'll notice is, like we mentioned before when we pulled it up, is just a simple select statement. So let me drop this for a second. So this will be like a simple select statement like you see here. It'll just basically pick up a bunch of the same columns and then maybe alias them. Maybe a couple here that need to be created and added and then aliased, or a string here. But for the most part, just a simple select and union statement, right? Now, what does that end up looking like here? Let's take a look. Here, we are going to first select the values here. And apologies, this was changed, but you're selecting a lot of these. And suddenly this seems like a little bit maybe longer than is expected in SQL, where you're kind of just able to plug that into one select statement and go from there. But this is to basically kind of create an easier way for us to alias it, right? Rather than create, you can do select.alias as, I just have it as a for loop down here for clarity's sake. But you can just as easily just say, select and then alias the actual column, right? And then we add the columns that we are saying need to be added with some sort of new synthesized data. So in this case, we need to cast it as a certain type, and then we're going to drop the original column that was there because it's a different type, maybe a string. And similarly with this, we're going to cast it to a date type and drop the original one, which is string. And then for a literal, which is what they refer to for, like a constant value in a column that you are adding. So that's what lit here means, literal. We're going to add this as a new column, right? And then for all of these columns, this is the original name and this is the new name. And I have to define the logic of saying, okay, we are going to now rename this column with, the said name here. So vendor ID will become vendor underscore ID. LPP pickup date time will become pickup date time, so on and so forth, right? And so this will be a kind of bulkier version of what you're looking at in SQL. And right now it may be like, okay, like why exactly is this better for me, right? Like what exactly is this benefit if I have to write more code for this, especially if it's code that I might accidentally mess up. And then before we get to, maybe the payoff here at the end, like yellow cabs will have to go through the same thing because we have to do that with the same data type, right? We have this giant select statement and union. So we have to make sure that they are of the same columns, right? So we're going to go do that. And then we're going to have this union occur here. right? And so that will handle everything for you. Then what you're going to see here is that now that that union is handled, I'm going to discard the changes here. We effectively accomplished what we're trying to do in all cab data. And in cab data, we have this. So we just have this mesh column or this add column, and then we have this pickup date, right? And here you'll see that we are actually just able to do that within one line, right? We just do a with column with a casting as a date type. So it's just as easy for Python to be easily translatable from SQL, where you have, maybe even less code than is present in the SQL query itself. So while there are situations where, yeah, it might take a little bit more syntax and a little bit more coding for you to do it, remember the flexibility that Python gives you is probably a little bit more than SQL in these more complex logic cases. This is, the basic thing, right, that SQL is good at, which is where SQL, you should still be using SQL, right, to be able to get to your basic stuff. But in the context of where we need to also, cut out overhead, where we also need to cut out these like little itty bitty things that will actually, eat away at the efficiency rather than the basic query itself. This is something that we should be looking into in terms of, okay, what does Python offer and how would I actually do that? So then similarly, this section, so pull that up here, this will be going through and how we parse, the JSON data. And so somewhere where we are able to kind of take a look at this, work with different APIs. Remember, this is a basic JSON string that we're pulling in as a read connector here. So from right here, you can take a look and see what we're pulling in here, but you'll see that we're getting a string of these values, right? A column of strings. And here we have to parse that, right? And so this may be like a JSON string, but for different APIs, they might have different outputs, and Python will provide a bunch of different libraries to be able to read these sorts of things. So in this case, you'll notice that we use the from JSON function in order to be able to interact with it. For other APIs, you may not necessarily have a JSON string, but you have other ones that you need to parse through. And for those purposes, like there are multiple different libraries that you can use through. Snowpark will provide it, PySpark will provide it. There will be a bunch of values that you can kind of iterate on. But similarly, so this should be, how we parse through that column of strings for JSON values, and then eventually get what we need to. You notice again, we have this group by, we have the aggregates, we add a column where, we have a conditional statement. So in this case, when, right, like case when, we just have when. And we're able to create, dynamic values based on that. And similarly, we have at the end here, you'll notice these are just 3 separate transforms, all within the section of like 20 lines of code, right? A lot of what these extra stuff is being able to, or extra, sections of code is being able to kind of cast stuff, clean it up, and normalize it, right? Rather than the actual functionality of the code. So I know we're running out of time, so I'm just going to briefly go over these last couple of sections. We want to get the average weather. So we're going to, basically pull things together, get a group by, and then average it out. And then lastly, kind of synthesize it all into a case when, have a couple extra things here at join, like a new column, have like a case when where again, we create dynamic values. And from there, you're going to see at the very end here, we're able to do that quite simply in like one line. This is again split up to be readable, but you can do this all in one line. You get the average weather data frame by grouping by on this weather date. You aggregate all, get the precipitation, and then call it average precipitation, and then join it in order to get, weather day. You join it on like the columns that we talked about before. In that column, it'll be a weather date and pickup date in that case. And then with the column, renamed with the conditional statement here. And at the end, you're able to return the exact same data, right? This will have the exact same output. You notice here that's 4.92 million records, 4.92 million records. And if you want to check the numbers, 4.916, 4.916, right? So at the end, we've effectively commuted these 7 down into this single one. Obviously, every single transform here will run a little bit faster than this whole transform here, but the whole transform hopefully should run a little bit faster than the 7 transform. If not, maybe it's not the best use case for it. If it is, that's all well and good. But that's up to you in your own, defined pipelines. This is not going to be a silver bullet that's like, oh, okay, if you switch to Python, everything will be faster. Or if you switch to SQL, everything will be faster. You have to find your own cases and figure out what works for you here and there, right? And these last 2 transforms, all they're going to be is, what you're pulling from there. Cool. So thank you for coming. I think that will be the wrap up to this section. And just before you go, and actually before we answer any questions, just why use Snowpark? We've gone over this a couple of times, but native integration with Snowflake functionality, enhanced performance scalability, unified development environment, ecosystem integration. I could go over this, but hopefully what you saw earlier was enough of proof that you can definitely use Snowflake for, or Snowpark, excuse me, for everything that you need within Snowflake in a much more cohesive manner. rather than using PySpark, which is an external system, or using only Snowflake SQL, which might be limited in it. Snowpark is a perfect kind of synthesization of what those two bring to the table and is able to actually perform up to both standards. So definitely do recommend it when you can. Lastly, resources for Python in general. For those of you who are new, I'm just going to briefly skim through this. YouTube, cannot overstate. It is actually a silver bullet. It will basically answer everything you do. I personally like free college courses. I am a Berkeley grad, so a little bit of a bias here, but I do really think that Berkeley 61A course is great for anyone to take. Having spoken to it myself, having not taken CS before it is really good at teaching people who have maybe not seen functional programming before. Textbooks, some recommendations for those of you who might be maybe a little more old school and prefer the book style of things. These are some great books that I think are good. I've not read all of it, but recommend it. Stack Overflow, for those of you who have specific questions or are like, I'm stuck at this specific place, perfect place to go. And lastly, random online tutorials. Python has an incredible amount of resources. If you work with SQL, I'm sure that you can randomly Google some queries and be like, okay, like here's what the issue is. That's Python to an even larger degree. You can get numerous libraries, numerous questions answered just out there. And like I said, it really is just that good. So strongly recommend it. Hopefully you get started doing Python. Definitely recommend it. And any questions? Cool. Roger, if you have your question, feel free to ask. How often will we be doing workshops? Yeah. So as we mentioned before, let me just flick back up there really quickly. We do have, onboarding sessions every Tuesday. So if you're kind of looking for something that's maybe a little more impromptu or on a scheduled basis, impromptu would probably be, kind of just messaging us and building up like a build session or whatnot. But alternatively, onboarding sessions every Tuesday. And Ishita will probably give you a more accurate response. I might be misspeaking a little bit here, but definitely listen to what she has to say. Yeah, and as always, if you have any questions, feel free to reach out. You can reach out personally if you want, but also just emailing Ascend or anybody there will definitely help you out. Yeah, we hope to see you next time. Definitely feel free to drop by. Missed more than half your session. Yeah, anybody who missed a section, showed up a little late, showed up a little early and had to leave. If this will be a recording, so you might be seeing this response later on, but yeah, you should be able to do this as well. Sure. Yeah, we might go into more advanced topics, and so we can cover those then. Again, those topics will probably be on Python over SQL, maybe not exactly like Python in this specific scenario. I think it'll be a little bit more around the conversation of data engineering, but I think you should still find it pretty useful. Is there a community? Good question. That is something we are currently working on. I don't think there is one actively right now, so it might be a little difficult to reach out to other people who use Ascend. But I do think it should be slated to become something that will be there very soon. Within I'm talking within the next month or two, hopefully. Don't quote me on that. With that being said, but hopefully we should be able to get you involved when that pops up. Yeah, there should be a follow-up email for those of you who are still here. And again, if you have no questions, feel free to leave, but we should be giving you an email afterward with the recording and I think any necessary links. Ishita will have a more thorough answer on that. Yep, thank you for coming. Great. So for those of you who are still here, thank you for coming. Very much appreciated. And we look forward to seeing you in the future.